There is a planet in our solar system that gives off more heat than it receives from the sun. No one knows exactly why. This frozen world lies at the edge of our solar system, where sunlight is 100 times weaker than on Earth. Yet, somehow, something deep inside Neptune is generating enormous amounts of energy. The same hidden force may help drive the fastest winds ever recorded in the solar system and power storms large enough to swallow Earth. Orbiting Neptune is Triton, a strange moon that travels in the opposite direction of the planet's rotation. Many scientists believe it did not form there at all, but was captured from the outer solar system billions of years ago. Even more remarkably, Neptune was discovered through mathematics before anyone ever saw it through a telescope. So what is really happening beneath the clouds of this distant blue giant? How did Neptune capture such a bizarre moon? And why does Neptune remain one of the greatest mysteries in our solar system? Neptune orbits about 4.5 billion kilometers from the Sun. That distance is equal to 30.1 astronomical units, meaning Neptune is more than 30 times farther from the Sun than Earth. As a result, it receives only about 0.1% of the sunlight that reaches our planet. If you stood on Neptune at noon, the sky would appear no brighter than twilight on Earth. Because it is so distant and so faint, Neptune cannot be seen with the naked eye. In the early 19th century, after Uranus was discovered, astronomers noticed something strange. Its orbit did not match the predictions of Newton's law of gravitation. Again and again, Uranus drifted slightly off course, as if an unseen giant at the edge of the solar system was tugging on it with gravity. Two brilliant mathematicians independently tackled the same problem, finding the location of an invisible planet. The first was the British mathematician and astronomer John Couch Adams. He completed his calculations in 1845, shortly after graduating from the University of Cambridge. But his work was largely ignored by the Royal Observatory in Greenwich. A year later, the French astronomer Urbain Le Verrier completed his own calculations in June of 1846. When French observatories showed little interest, he sent his predicted coordinates to Johann Gottfried Galle at the Berlin Observatory. On the night of the 23rd of September 1846, shortly after receiving Le Verrier's letter, Galle and his assistant pointed their telescope toward the predicted location. In less than an hour, they found Neptune. The planet's actual position was only about 1 degree away from where Le Verrier had predicted it would be on paper. Later, the physicist François Arago praised Le Verrier as the man who had discovered a planet not with a telescope, but with the tip of his pen. According to conventional logic, the farther a planet is from the Sun, the colder it becomes. And the colder it is, the weaker its atmospheric activity should be. Yet Neptune is astonishingly active. Its winds roar across the planet, clouds race through the sky at incredible speeds, and gigantic storms constantly form and evolve. If you could stand within Neptune's deep blue atmosphere, you would witness a weather system of immense power and mystery. Winds can reach supersonic speeds of up to 2,100 kilometers per hour. That is nearly twice the speed of sound and about 9 times faster than the most destructive hurricanes ever recorded on Earth. Even more strangely, these supersonic winds blow in the opposite direction of the planet's rotation. In 1989, the Voyager 2 spacecraft captured the first images of the Great Dark Spot in Neptune's southern hemisphere. Scientists initially believed it was a massive, low-pressure storm surrounded by thick clouds. In reality, the Great Dark Spot appears more like a gigantic hole in Neptune's upper methane cloud layer. It opens a deep window into the atmosphere, allowing us to peer into the darker and deeper layers hidden beneath. By 1994, when the Hubble Space Telescope turned its gaze toward Neptune for a closer look, the enormous storm had vanished completely. Unlike Jupiter's Great Red Spot, which has persisted for at least 300 years, Neptune's Great Dark Spots can form, drift across the planet, and disappear within just a few years. Soon afterward, Hubble detected new dark spots appearing in different locations, including one in the Northern Hemisphere in 1994 and another in 2018. The planet seems to be constantly recycling its atmosphere, repeatedly generating new superstorms. At a distance of about 4.5 billion kilometers from the Sun, sunlight alone is far too weak to power such extreme weather. Scientists have found that Neptune radiates approximately 2.6 times more energy than it receives from the Sun. This internal heat source stirs the atmosphere from within, driving the planet's violent storms and terrifying supersonic winds. But where does this mysterious energy come from? To find the answer, we need to journey deep inside Neptune, passing through its layers one by one. The outermost layer is the atmosphere, composed primarily of hydrogen, helium, and methane. It is the methane that gives Neptune its iconic deep blue color by absorbing red wavelengths of sunlight while reflecting blue light. Deeper still, we encounter an entirely different layer, a vast, high-pressure ocean, not made of ordinary water, but of a dense mixture of water, ammonia, and methane compressed under immense pressure. And at the very center, hidden beneath it all, lies a solid core of rock and metal. As we descend from the outer atmosphere toward the core, the pressure rises to unimaginable levels, reaching millions of times the atmospheric pressure at Earth's surface. Under such extreme conditions, matter no longer behaves according to the familiar laws of physics we experience on Earth. Something almost unimaginable begins to happen deep within the planet. Methane, one of the primary components of Neptune's atmosphere, contains carbon within its molecular structure. As it is forced deeper into the planet under crushing pressure and intense heat, the chemical bonds in methane break apart, separating the carbon atoms from the hydrogen. Those carbon atoms are then compressed together, crystallizing into diamonds. In fact, scientists predict that the diamonds forming inside Neptune could be as large as a human fist or weigh millions of carats. Because these diamonds are denser than the surrounding material, they begin to sink, slowly falling through the super-pressurized ocean toward the planet's core. As they descend, friction between the diamonds and the surrounding material generates heat. That heat gradually rises through Neptune's interior, eventually escaping into the atmosphere. This enormous internal heat source acts like a giant furnace deep within the planet, continuously pumping energy outward, stirring the frigid atmosphere and driving the violent winds that blow opposite to Neptune's rotation. This is currently one of the leading explanations for why Neptune radiates significantly more heat into space than it receives from the Sun. But Neptune holds another mystery. This time, it isn't the planet itself that raises questions. It comes from Triton, Neptune's largest moon. Almost every moon in the solar system orbits in the same direction as its parent planet, because they formed together from the same primordial disk of gas and dust. Triton is different. It travels in the opposite direction, a retrograde orbit so unusual that very few other large moons possess one. This bizarre motion has led scientists to believe that Triton may not have formed alongside Neptune at all. The leading hypothesis is that Triton was once an independent dwarf planet, wandering through the distant outer reaches of the solar system before Neptune's immense gravity captured it and pulled it into orbit. But the story doesn't end there. Because Triton moves in the opposite direction of Neptune's rotation, tidal interactions are slowly draining its orbital energy. As a result, it is gradually spiraling closer and closer to the planet. According to current models, hundreds of millions of years from now, Triton may drift close enough for Neptune's enormous gravity to tear it apart. But those fragments won't just vanish into space. They're going to spread out and form a massive ring system around Neptune, potentially making it look even more stunning than Saturn. For all that we have discovered, Neptune remains a world of unsolved riddles. The phenomenon of diamond rain, though supported by physical models and laboratory tests, has never been directly observed. The source of the planet's internal heat continues to spark debate among scientists, and Triton, with its strange backward orbit, is still steeped in mystery. But here is the most astonishing part. Practically everything we know about Neptune comes from a single visit lasting only a few days, courtesy of Voyager 2. Right now, there are multiple proposals for new missions aimed at putting a spacecraft into a permanent orbit around Neptune, rather than just passing through. We have walked on the moon, we have pushed deep into the cosmic frontier, but this blue gas giant, 4.5 billion kilometers away, has only ever seen a single visitor. And perhaps Neptune's greatest secrets are still waiting to be discovered.